what does the Greshoff's rule say? That note down this equation, note down this law, guys. This is very important. Now, yesterday I've told you the sum of the longest and shortest link must be less than the sum of other two links. This came from the famous triangle of inequality. So what the triangle of inequality is? Suppose this is my triangle. This is my two sides A1 and A2, and my side A3. Side 3 is the longest side. You can't form a triangle. The triangle will always be formed when A3 is lesser than A1 plus A2. Okay, you can't form a triangle when A3 is greater than A1 plus A2. You got it right. This is the triangle of inequality. The same works for linkages. Suppose if the position, assume this is theta, the theta is like 180 degree, means this is how this particular linkage will look like. Okay, you got it right. L plus S. Now this S plus L is nothing but my longer side of the triangle A3. So L plus S should be lesser than P plus Q. So this is the definition of Greshoff's law. He derived from the triangle of inequality only. So so what does the Greshoff's law tells that for a complete rotation of the crank, okay, the sum of longest and shortest link must be less than the sum of other two links. Note down the equation. And yesterday some of the inversions of 4 bar has been discussed. So if I'm fixing the longest link, means I will get a crank and rocker mechanism. Crank means a full dimension. What is a crank means? Suppose this is a 4 bar mechanism, means okay, a crank means a full rotation. So a link which will be going a full rotation is nothing but crank. Okay, a link which will be oscillating on the point, this is nothing but a rocker. So if I'm fixing the longest link, means I'll get a crank and rocker mechanism. If I'm fixing a link opposite to rocker, something like this, okay, for this also I'll get a crank and rocker mechanism. If I'm fixing a link, shortest link, means I'll get a double crank mechanism. These two links will have a complete 360 degree rotation. What is the example of double crank? Railways engine, right? So railways engines will have a double crank mechanism. You know that, na? This is how the railways engine. So it's a double crank mechanism. Then if you see the wheels of the railways things, the links will be like a double crank mechanism. Then other thing is like if I'm fixing the link opposite to the shortest short link, means it is nothing but double rocker mechanism. So wipers. So double rocker mechanism. So these are like some of the inversions of 4 bar mechanism. And yesterday I taught you how to find the degrees of freedom for this structures. Everything has been discussed yesterday. You can go and refer the previous videos. Then what is a mechanical advantage? A mechanical advantage is nothing but this is our concept, right? The power input should be what are the power transmitted given to the input is equal to the power transmission at the output. So power is nothing but T1 omega 1. Okay, guys. So here I'm mentioning this as T2. T2 omega 2 is equal to T4 omega 4. The mechanical advantage is nothing but T4 by T2. Okay, otherwise omega 2 by omega 4. What practically the mechanical advantage means? Suppose I'm giving 2 Newton meter torque in the input. If I'm getting 4 Newton meter torque in the output link, then I can say that my mechanical advantage is 2. You got it right? So mechanical advantage means how it enhances the input, input torque or other things. So that is mechanical advantage. I'm giving only 2 Newton meter torque as input, but I'm getting 4 Newton meter torque as output. That is a mechanical advantage, right? That's what mechanical advantage means. So note down this. This is a famous one word for. They will be asking this frequently in GATE, ESC, and TANGEDCO everywhere. This is one of the famous one word, which means during the toggle position. The toggle position means once the link goes to the extreme point. This is the link. This link I'm saying this is like L1. How the L1 is a rocker, right? This is the position of the L1. This is how. This is nothing but the toggle positions. The extreme where it changes its side direction. Where the link changes the direction is nothing but toggle position. The mechanical advantage of toggle position is nothing but infinity. So note down this particular thing. Then transmission angle, guys. This angle is nothing but the angle I'm mentioning here. This is nothing but the transmission angle. Okay. So this transmission angle is very important because the reason is the torque transmitted is maximum when mu is equal to 90 degree. Okay. So whatever the torque I'm giving in the input, the torque transmitted will be maximum when the transmission angle is 90 degree. So that's why this transmission angle is important. Okay. So for a particular mechanism to find how much maximum torque can be transmitted, right? For that we have to know about this transmission angle. So the mechanism will jam if mu is equal to, if the transmission angle is 0, means the mechanism will jam. So note down these 2 points. This is more than enough for exam point of view. Okay. Suppose if they're asking, they're giving you one mechanism and they're asking to find, this is our mechanism, and they're asking to find the maximum transmission angle, means for our mechanism. Just make the theta as 180 degree. If the theta is 180 degree, means this is where the maximum, this is what my maximum transmission angle is. Then if it is rotated, means this link will close down. Okay, the link will be in maximum position when theta is equal to 180. Okay, that's where my maximum transmission angle is. Then use law of cosine's formula. So a plus d, the whole square is equal to b square plus c square minus 2bc cos nu. So the opposite angle. This is the law of cosine formula, guys. Already I've given you the formula in mechanics first chapter. Okay, first thing lecture. Go and see the formula. Say using this formula we can find the mu max. Okay. Anyway, I won't think they won't be asking this in our TNUV exam, but note down this for people who are preparing for ESC and other things. Okay, ESC and ISRO and all. Then double rocker mechanism, the same concept. The mu max will be maximum when theta is equal to 180, guys. Same concept, and find the other things. Then yesterday I have given you some of the inversions of slider crank and double slider. Okay, for a slider crank mechanism there are 4 inversions. Okay, if link 1 is fixed, means this is nothing but the reciprocating engine, that is IC engines. Okay, IC engines. Then if link 2 is fixed, means I will be getting Whitworth quick return motion mechanism. Now if link 3 is fixed, means I will be getting a slotted lever crank mechanism, that is shaping machines. Okay, if link 4 is fixed, means I will be getting a hand pump. For similar to the 4-bar mechanism. So see here. Similar to the 4-bar mechanism, if I'm fixing the each and every link, I'm getting the corresponding mechanisms, right? 4 inversions are there. Similarly, this is the inversions of 4-bar. Similarly, the double slider will have, yeah, I'm saying right here, right? Yeah, the slider crank has 4 mechanisms. By fixing each and every link, I will be getting different mechanisms. Similarly, this is double slider. Okay, if I'm fixing the link 1 means, if fixing the link 1 means I'll be getting elliptic trammel, which means the rotation of the motion of this, there's nothing but a elliptical trammel. It will be elliptical. You'll be getting a elliptical trace. That rotation will be elliptical trace, elliptical trammel. The second inversion is nothing but Scotch yoke mechanism. Scotch yoke mechanism means I'm transmitting a rotary motion into a linear motion. That will be nothing but a Scotch yoke mechanism. One rotary motion will be transmitted as a linear motion. Then third one is nothing but Oldham's coupling. If I'm one more inversion is, the third inversion of double slider is Oldham's coupling, which is used to connect a shaft 1 and shaft 2 of different different centers. So used to connect eccentric shafts. Okay, transmitting power between eccentric shafts. For that you can use Oldham's coupling. And the double slider doesn't have a 4th inversion, guys. It doesn't have a 4th inversion. Only it contains only, because if you see 4-bar mechanism and slider crank, it has 4 inversions, but double slider will have only 3 inversions. So that's all